Hey everybody, today we're going to learn how to draw something called a motion map. Now so far, whenever we're looking at the motion of something like the buggies in the buggy lab, or we could be looking at a skier or a skater or something like that, we know how to do motion using a couple of different tools. Number one, we could draw a graph, specifically a position time graph. And we've talked about how do we see the velocity, how do we kind of represent motion on an XT graph. We also, we could use an equation. And the equation that we derived from our lab is the basic velocity equation, where the velocity is equal to the change in the position over the change in time. And that's great. We love graphs, we love equations, but a motion map is the third way that we're going to learn how to describe the motion or analyze the motion of an object. And a motion map is a little different. It's a little bit like a stop action kind of film or like a strobe light, where we're actually going to take a picture or flash a light on certain moments in time, and we're going to locate the object in that moment. And then we're not going to look at it until another moment has passed. For example, if you look here at these skiers, if I'm just watching that video of the skier, they're making one smooth moment. In the top picture, he's coming up off the half pipe, he's doing whatever that move is called, and then he's landing back down. And it only lasts like a fraction of a second, and then it's over. But if I have a camera and I can take a picture every 10th of a second or every 100th of a second, then what I can do is superimpose those pictures on one another, and I get the kind of pictures that I've got here. I can see, where is the skier at this moment in time? Where is he at this moment in time? At this moment in time? And so on and so on. And I can actually break the motion down into what is actually happening moment by moment, second by second. We call this kind of diagram a motion map. It's going to look, in its simplest terms, like the diagram there at the bottom of the screen, right here, where we're going to have sort of a line here. This is a position line, and that little X right there tells us that this is a number line, but the numbers represent the position of the object in meters, and then it's going to have dots and arrows on it. Now, let's learn how to draw these. Okay, so a motion map has a couple of basic parts. Number one, it's got a line, and this line represents the position in meters. That's this line that you see right here. I'm going to draw an arrow on the end of it. Usually we draw our position lines with arrows on the end, and you will notice here that this is marked with an X for position, and that this line also has kind of hash marks on it. We don't know what in this diagram they represent. They might be 1 meter intervals. They might be 2 meters, whatever you need for the problem that you're going to try and diagram or draw. Then you're going to have a dot. The dots, that's kind of right here. These dots right there. That one doesn't want to draw, sorry. Those dots represent that moment in time that we were talking about. And we place the dot on the line exactly where the object is at that moment in time. So let's say this is 1 meter, 2 meters, 3, 4, 5, 6, 7, and 8. I'm actually going to, if I look at this moment in time, this first one that I have highlighted, that tells me that the object at that moment in time is at 1 meter from the starting line. The next object is at 2 meters. So the dot is placed at the position where the object is at every moment in time. If we have numbers that go along with us, this allows us to actually calculate out the velocities, and it lets us figure out what's happening with the motion of the object second by second, because each dot represents, in general, 1 second, and in meter by meter, because that's what is represented on the position line. Now, typically, when we do this, we are going to mark the start, and you'll see why later, and we're going to mark the end. It is always extremely helpful to do this. You will find out as these get more complicated, it can be hard to tell which is the beginning and which is the end, so we always mark it. And then you will notice in between the dots, we have these arrows, like right there. I'm coloring them like a reddish orange. Those arrows are velocity vectors. They show the magnitude of the velocity by how long they are, and they show the direction of the velocity by which direction they point. Now, we're going to have very simple to the left, to the right, up, down, that kind of stuff. So you draw the arrow in the direction that the object is moving. One very important thing is highlighted at the bottom. Always draw the arrow 1/2 the size of the space between the dots. You will see what I mean, okay, and why this is important as we kind of practice a few of these. That is really important. The number one way to get an orange instead of a green on a worksheet or on something involving a motion map is to make your arrows too long or like way too short, because the arrows there, we want them halfway between the dots for a reason. So let's take a look at what this actually looks like in practice. Okay, so I've got 3 situations here, and the first one is at the top, and I've got a car that is traveling to the right, and I have my position line there underneath. I don't have any numbers here, and that's okay. All I'm trying to do is learn how to draw here. And one very important thing is I want to decide right up front where am I going to draw my dot on the car. You could put the dot at the middle of the car, at the beginning of the car, at the end of the car, the back. I'm going to put my dot like it's going to represent this right here, like the back bumper of the car, just because that's what's kind of on the starting line here. And I'm going to draw my diagram below. So at the first moment in time, my car is going to be right here. And I'm going to make sure to write start so that I know where I'm starting. Then I'm going to draw the next dot. So at the next moment in time, there's the bumper of my car. I'm going to come down and I'm going to draw my dot right there. And once I've done that, I'm going to go back to the previous dot and I'm going to draw an arrow halfway to the next one. Now remember, each dot is a moment in time, and the line represents position, and the arrow is a velocity vector for this car. I'm going to just continue. So I'm going to look at the third moment in time. There's my bumper. I'm going to bring that down. I'm again going to draw my arrow halfway in the direction the car is moving. And I mean, look, it doesn't have to be perfect, but I have to be clear that you're drawing it halfway. And I'm going to draw the last one. There's the bumper for the last moment in time right there. And I'm going to draw that arrow halfway. Now, the car may continue to move. It may stop. So on this last one, you can just draw that arrow ahead like that to show that the car keeps moving unless you're told that it stops. Now, take a look at what I've got here. I have positions for 4 different moments in time, and I have 4 different velocity vectors. Notice that those velocity vector arrows, they're basically the same size. And that's important because that tells us that the velocity is basically the same from moment to moment. You can recognize constant velocity when all of the arrows in your motion map are essentially the same length. Now, let's take a look at the next one. 3 seconds pass in this one. Let's change color. And again, I'm going to draw the back bumper of the car, like right there. And so my first dot is going to be there. It's going to be start. Ooh, guess who didn't write end on this? Bad. Okay. I write start. I'm going to go to the next moment in time. There's my bumper. I'm going to draw my dot. And my arrow goes about halfway. I'm going to go to the third moment in time. I'm going to locate my bumper and I'm going to bring it down here. And I'm going to bring this over halfway. And then I'm just going to continue that arrow like it was. Now, notice something here. The arrows are bigger. And because those arrows are velocity vector arrows, that means that the velocity for the purple car is greater than the velocity of the blue car. And that means that the purple car is traveling faster. You can just look at the arrows and you can tell, number one, constant velocity, because the arrows are all roughly the same size from moment to moment to moment. Number two, velocity is to the right. And number three, the purple car is bigger than the blue car. Okay, last one. I'm going to have to pull this up a little bit. Last one. Let's take a look at this one. This one's interesting because it's traveling from the right to the left. Before I do anything else, I'm going to come up here and I'm going to write end, because I always forget to write end on mine. So on this motion map here, where is the first moment in time? It's actually the third car. And I'm going to continue my practice of marking the back bumper. So there's the spot that I'm going to mark on my motion map. For instance, I'll come down here. I will mark that moment in time at that position. Then I'm going to go to the next moment in time. There's the bumper, so I'm going to come down here and mark it. I'm going to draw my arrow halfway. And then the third moment in time, I'm going to come down and mark that. And again, I'm going to draw my arrow about halfway. And then I'll just draw this last one about halfway too. Notice the velocity vector. The arrow shows the direction. It's traveling to the left now. I'm going to make sure I mark my start and my end position. And that's how you draw a real basic motion map. We take a look at each moment. We draw a dot at the correct location. And then we draw arrows that are about halfway the length of the space between the dots. Now, motion might get a little more complicated. For example, maybe an object sits still for a few seconds, and maybe it reverses directions and different things like that. Typically, if an object sits still, we stack points vertically to show that the object isn't moving, because essentially it's at the same position for several seconds. And you can see that kind of right here at the bottom. We start over here. We travel 1 second, 2 seconds, 3 seconds to the right. Then we pause at 4 seconds and we stay in the same position. And then at 5 seconds, we stay in the same position. Then we start moving back to the left, and then you have 6 seconds, 7 seconds, 8 seconds, and 9 seconds total. So these moments where the object is resting or sitting still, you just stack those on top of one another. That allows us to count how many seconds it stayed still. You also want to just be really careful. Label, label, label. Make sure that you label the start and the end of your map, and be very neat so that it's very easy for people to read. Okay, right now I want you to practice a few. I want you to practice number 1. So I'm going to read it to you, and then I want you to stop the video, and I want you to try and draw a motion map for this situation in number 1 on a piece of paper. You are going to eventually upload your attempts. Don't worry about being right or wrong at first. Just do your best, and we'll just keep going over stuff until you get it. So for number 1, a car moves in the forward direction. That's typically to the right when we draw things. Quickly, at constant velocity, stops for a few moments, and then moves backwards slowly. Notice here you don't have any numbers, so there's many different ways to draw this. Try right now, pause the video, and try and draw a version that would be consistent with that. Okay, let's see what that might look like. So the car is going to move in the forward direction. First thing I need to do is turn off my highlighter and turn on my pen. How's that? Yeah. So the first thing we need to do is we need to draw that position line. It starts with an X, and I'm just going to draw that arrow the entire way over. Remember, this is meters. This is position in meters. Then I want to show a car moving in the forward direction. It doesn't tell me where the car starts. I'm just going to start it at the beginning, but you could have started it anywhere. I'm going to start my car right here. And if the car is going fast, that means it's covering a pretty big displacement, in not very much time. So as 1 second passes, maybe it travels the whole way over here. And I've got a great big velocity vector. Then another second, it goes that same amount. And let's just go 1 more second. If you didn't do as many, or if you did more arrows and dots than me, that's totally okay. It's going to be the shape of this thing that's going to let you know if you understand. Now, here it says that it stops for a few moments. If it stops, that means that it's going to be in the same position. So if this is the position where the object is, then that object is going to stay there for a few seconds, however many seconds that is for you. Maybe you drew 2, maybe you drew 3. If an object is not moving, it has 0 velocity, which means there's no arrow, okay? So we don't put any arrows there. And then it moves backwards slowly. Now, if it's moving slowly, it's not going to travel as far every second. And so I want my arrows to be smaller, which means I want my dots to be closer together. And it doesn't say how many seconds, and so as long as you drew something going to the right with bigger arrows, then a couple of dots sitting on top of each other, and then some closer dots with smaller arrows heading to the left, you're going to be just fine. Now, let's take a look at number 2. Number 2 is actually, I think, maybe a little easier to work with because it actually has numbers. So I want you to do what you just did the last time. I want you to stop the video. I want you to read through this one, and I want you to try and make a motion map that goes along with this. And then once you're done, come back and play the video and see how you did. Okay, so in this case, I need to do the same thing. I need to draw that position line, draw it way out. But this time, I actually have numbers and stuff. So I'm going to put hash marks to represent 1 meter intervals on my number line. So I'm going to say 1, 2, and I mean, I'm just doing this by hand, so I'm just trying to be as sort of, you know, fancy as I can. All right, so this is going to be 1 meter, 2 meters, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and remember, this is meters. Now, the car starts at 3 meters. So that means right at 3 meters, this is where my car is going to start. So I'm going to draw my first dot there. Then it's going to go backwards for 3 seconds at 1 meter per second, meaning 1 meter every second. So I'm going to go back 1 second. I'm going to go back 2 seconds, another meter. Ooh, that was a bad arrow. And I'm going to go back 3 seconds. This actually puts me at the starting line. And you can see that my arrows are roughly the same shape. Not perfect, but close enough. Now, it stops for 3 seconds. I think that it helps to number your seconds here. Okay, so this is t equals 0, or the start. This is t equals 1 second. T equals 2 seconds. This is t equals 3 seconds. If I'm going to stop for 3 seconds, then I need to stop for 1, 2, 3 seconds. That's going to be t equals 4, t equals 5, and t equals 6 seconds. It's real easy to lose a second when you're stopped, so I always count it all out from the beginning. And then it tells me I move forward for 3 seconds at 2 meters per second. So now I'm going to draw every dot 2 meters apart. So I'm going to go forward now to the right, and my next dot's going to be here. And I'm going to have a much longer arrow because I'm going twice as fast. And then that's going to be the next second, which will be t equals 7. Then my next second is going to be 2 meters ahead at 4. That's going to represent 8 seconds. And my final second dot is going to be at 6 meters. And that's going to be t equals 9 seconds. Make sure that we put the arrow in there. I'm going to write end. And notice that, you guys are going to call me out on this so many times in class. I'm the worst at writing start and end, even though I will harass you no end to write it because it helps me read it better. So this is really straightforward. The only tricky part is occasionally it's easy to lose a second here and there, to miss a dot. And so just go back and count through the seconds, label the seconds if that helps you. If it doesn't, you don't have to. But this is how you draw a motion map. Now, if this makes sense to you, awesome. You're ready for the next questions in the formative. If you're struggling with this, go back and kind of listen to it again, or you can even go on to YouTube and Google motion maps and see if maybe there's another video out there that might explain it more or in a different way that's more helpful to you. Or if you have a specific question, message me through Teams, and I will do my best to get back to you as soon as I can. Hope you are having an awesome day, and I will see you soon. Bye.